Welcome everybody. We're going to get started here in just 1 minute. All right, I think we're going to get started here. Wanted to say welcome to everyone. Today we're going to be learning about cloud HPC with TotalCAE. We're going to be hearing from Guangdong with Lucid Motors on how they use TotalCAE on AWS, and Isaiah Weiner on HPC on AWS. At the very end, we'll have a $500 cloud credit for anybody who wants to try out the TotalCAE public cloud on AWS. And you can use the chat button to the right. If you have any questions, we'll try to answer those here at the end of the call. If for some reason we don't get to your question, we'll definitely follow up with you afterwards. So to get started, a little bit about why would you want to use public cloud? Just as a refresher, one of the things you can do is you can access a lot of HPC compute resources quickly to run simulations on demand. So let's say you need to run a few thousand core CFD simulation. You can do that with just clicking a few buttons, and suddenly you're able to run a large-scale CFD simulation that you might not have been able to run before on a workstation, or the result would not come back in a timely fashion for you to get the result back. It also allows you, if you have a cluster on-prem, to avoid waiting in queues. So if you have a lot of workload and maybe you're a supplier that has to get a result back to the OEM by morning, you can now skip ahead and run that on cloud and get that answer back in time to meet your simulation deadline. Another popular use case is running large simulation DOEs, where you run thousands of iterations to find the best design using some type of design of experiments tool, and you can run those on cloud to optimize your design. Now, many times you may not have a data center to put thousands of compute resources in, and you could use cloud to basically rent those compute resources so you can access thousands and thousands of compute cores that you may not have a place to put or the budget to put such a large supercomputer in at your facility. And in the old days, you might just buy a workstation to get your results back quicker, but the clock rates on CPUs have been stalled out for many years, and really you need to add more CPUs. Most CE applications, when you add more CPUs, you can get the result back faster. So every time you double the CPUs, you have the time you're waiting for the result. And so you can get up, in this example, this was an LS Dyna model that we ran. 500 cores was able to get that runtime back to get more designs done per day and get more engineering done to impact the design quicker. And as you can see from the graph, on-premise and cloud have the same exact kind of performance. And as long as you choose the right type of instance for the engineering workload that you're doing, then you can get those results back quite quickly. So if HPC is great, why isn't everybody using it today, and why isn't everybody using cloud? Well, part of the challenge is that cloud and HPC are complex. There's a lot of technology that goes into putting together a turnkey production system on the cloud. There's also you have to understand all the engineering applications and Linux, batch schedulers. There's a lot of complexity that goes into making a solution. And many times your IT team may not have all the skills necessary. We call them ITC ninjas. They may not exist and they may be difficult to obtain. So TotalCAE basically has a team of these ninjas, and that's kind of what we do is we make HPC easy to use. We basically have simulation as a service. You can run hundreds of engineering applications on the cloud in just a few clicks. And then what we do is we manage all of that complexity for you so you can focus on engineering and not on IT. So on AWS, our platform leverages many of the AWS services. And you don't necessarily have to understand how they all work and put together. You can really just focus on your engineering application problem you're trying to solve, and we take care of everything else behind the hood. So everything that happens in between for hundreds of these applications that we support, from the time you push the button to you get your result back, everything is on TotalCAE's shoulders to make sure that you get the engineering work done. So we basically can draw a dotted line around the cloud, your applications, your license servers, everything that you need to get your simulation done. And then we take care of that as TotalCAE, of just one vendor, one throat to choke. And we definitely measure engineering success on every single problem, question, issue that you have. You will get an email asking you to rate how you thought it was handled. And if we don't get a 100% positive response, and you will get a call from myself, the CEO, to just see what we can do to make it better, make sure we can resolve that problem. Every week we put quotes, new quotes that we get from clients on our website. We get a lot of kudos for fast response. We have 1 hour response time on all issues, and helping people get their job done, because we know engineers are under a lot of pressure to get simulation results done, and we're here to help out on that. So one of the other things we do about making HPC easy on cloud is we do have a web portal. It's just for all these applications, you basically have just a couple things you have to do to run on AWS. You basically select your application, the version, you upload your input deck and any includes, and push the submit button. Pretty much that's it. And after that, you'll get an email after we've turned all the machines on, crunched the numbers, and you can then get the results of a variety of ways. Download them. They might show up on-prem. You might use a remote viz to post-process. And that interface is the same whether you run on-prem or on the cloud. You can run HPC anywhere, and you just don't have anything new to learn. You just change where you point your browser. Everything works the same. It also has a command line interface and an API for hooking up with various tools. So you don't have to use the portal if you don't want to. But it definitely makes it the most simplest to use and kind of democratizes HPC for a wide class of engineering users. So when you go to the cloud, one of the things that will be a little bit different than a workstation or on-prem is that each job you do pay to rent the compute time. So while it's great to rent thousands of computers, those do cost some money. So if you run a simulation you maybe never ran before and you have some typos in your input deck and it fails, you actually do have to pay for that. And so when you go to the cloud, one thing you want to do a little bit differently is make sure the models that you're running, maybe you want to test, make sure it iterates a couple times and then submit it, so that you'll know you won't have to pay, for time that you're not using. So usually you'll have a budget of some kind of simulation budget, and that's usually reviewed. You'll see all the jobs that have ran, and there'll be a job cost on each job, so that some kind of CE manager or person in charge of the budget will review to see how their simulation dollars are being spent. So in our system, we do make that easy. So each job, when you submit it, it'll tell you how much that job will cost, and you can put some seat belts on it. So for example, if you're like, this job, if it may not converge, it may not give me the right answer. So if I don't get it back in so many hours, I don't want to continue to pay. So you can put seat belts on to kind of cap the cost for each job. And we can then help you, organize your simulation jobs into projects and budgets, so you don't exceed any particular project spend that you may have for a certain project. In addition, we let you put in some comments so that at the end of the job, at the end of the month, when you're reviewing all of the job spend, you can have some comments on why that particular simulation was run to help justify the different costs. Now, everybody on the call knows that simulation saves the company money, but that still there's usually some type of budgets, and so these tools will help you work within it. Something unique to TotalCAE is that we often have clients, there's different engineering solvers may not exit cleanly, or they may not converge, or may hang up, have various kind of application level issues that may still cause you to be paying for the compute time. And so we have application aware monitoring where we actually look at the output that's coming out of your job, and if we see something that looks amiss, maybe we see that there's some kind of unusual error, we'll email you and flag it to say, hey, you might be paying some compute time that you don't need to for this particular run. You may want to inspect it to see if it's behaving properly, and if not, then you can go ahead and cancel it, instead of maybe letting it run for a day or two and then finding out you aren't getting the solution that you had hoped. The other thing to be aware on cloud is there's definitely different application licensing to be aware of. We use a bring your own license, so we will either host your license server for your application, or we will have some technology to let us access it from the cloud, from on-prem. And even though we can access license serving anywhere, there are some things to be aware of. For example, many of the ISVs have licensing strategies that restrict who can access it by geography. some legacy rules like the engineer has to sit within 25 miles of the license server, for example. So often these are just simple paperwork that have to be done. There's some ISVs that do have like licensing that you can do by the hour. For example, CP Adapco has Power on Demand with Star CCM Plus, now by Siemens. And there's also, sometimes they'll have vendor EULAs which prohibit you from running their solvers on rented hardware. You'll have to then basically just get a little paperwork form typically to get it checked. But we can help you with that. We've worked with hundreds of engineering apps on cloud and we're pretty familiar with the various vendor rules and can help guide you on that. Now, the final challenge that we do often during a cloud pilot is that these data centers do exist remote, and AWS has a lot of data centers around the globe that we can put close to your engineers. But still, sometimes you may have a bad internet connection, or maybe it's shared with many customers, and if you have hundreds of gigs that you have to download for each model back to the internet, there can be some bandwidth challenges. And so we offer some technology to help around that. On AWS, they have nice DCV, which is kind of a remote viz solution. So we don't necessarily have to bring the model back. For example, with Star CCM Plus, maybe you just need to change the mesh and then resubmit. Instead of downloading 200 gigs, clicking on the mesh and re-uploading 200 gigs, you just have a workstation in the cloud. You just change the mesh, resubmit it. It's all, and that cloud workstation is right next to the data, so it's very fast. They also have, in our case, we can hide the download latency. When your job finishes, we can actually stream it automatically on-prem. So let's say your job finishes at 1 a.m. When you get into work at 8 a.m., it's already there. You didn't have to click the download button and then, wait for things to download over the internet. There's also other technologies such as FemZip and compression tools and many other solutions. We have a post on our website all about speeding up downloads from cloud. You can also have a special high-speed connection, which your company may have already into AWS or other cloud providers that will speed that download up and make it more seem just the same as a on-prem data center. So finally, we're going to have Guangdong here from Lucid Motors talk a little bit about their experience with TotalCAE on cloud, a little bit about what they do. So I'm going to take one moment here and pass the baton over to Guang. Just one moment. All right, you are the presenter. And here's Guangdong from Lucid Motors. Thank you, Guang.
Thank you, Rob. Thanks for the introduction. So can you see my screen?
It sure can.
Yes. Yes.
Okay, good. Yeah. So thanks, Rod. Thanks for the opportunity. Let us present in this webinar. So first, I'm from Lucid TotalCAE team, and we are an electric car startup at the Silicon Valley. And so first, a couple of slides, they're talking about the company a little bit. So the company's mission is to develop definitely a new luxury electric vehicle and center around with the human experience, which is definitely very important for the product. And the second highlight point is our first product, the Air. It's targeting the very big luxury sedan market. And the next highlight point of the company is so our manufacturing factory is located in Casa Grande at Arizona, and with targeting SOP for the end of next year. So, and also the company has developed the very competitive battery and the powertrain technology in-house. So we are targeting 400-mile range and 1,000 plus horsepower from the powertrain. So a very a big highlight of the product is although the car, if you look at it from the outside, it's not that big. For example, we having the same size to Mercedes E-Class, but actually the interior space is very spacious, and we are having the same interior space as the Mercedes S-Class. So that's why we call the product Air. It's like, the car does not exist and only the interior exists. So it definitely is fully electric and 0 to 6 mile per hour in less than 2.5 seconds, and 400 miles range, and the fast charge capability, and also the car will equip it with autonomous driving hardware. So next, I'm going to talk about how we use the CAE tool in our product development. So these days, CAE tool is a very important tool in product development in automotive industry. This especially for crash safety, because crashing a car is very expensive and time consuming because of the prototype building process. But luckily, we have the CAE tool. We can run the simulation, everything on the computer, and we correlate our CAE model to the physical test. So in this video, you are seeing a crash structure in high-speed bending test, and the left animation is our CAE simulation, and the right is the physical test. So we tune our parameters in the CAE model to match the CAE results to the test results. Then using this correlated CAE model, we can do next iteration, such as changing the geometry, changing the thickness, and changing the fastening strategy. Then all this can be done in CAE tool, which can accelerate the development process a lot to save us both time and cost. Yes. So next slide, I'm going to talk about why we go with TotalCAE Cloud. So as a small company here, we definitely have a quite big computing resource challenge. Although we do have on-site HPC, but for some peak time, for example, a lot of urgent work, we definitely need more resource than the HPC we have on-site. Because the design pace is very fast here, and the designer are expecting the CAE simulation to give them direction, next day. So using the cloud, we do have a more capacity on urgent situation or on peak time to give us a quick turnaround time. So few big benefits from the TotalCAE public cloud is as the first one I already mentioned is the turnaround time. It's definitely it's faster than just to rely on our on-site HPC. So the second one is also very important is the portal is same as our on-site HPC portal. So there's nothing changed for using it on cloud. So it's very simple to use, just very straightforward. So next one is definitely for as a CAE engineer. So we only focus on to solve the engineering problem, to help with design, and all this cloud complexity and the IT support. This has been done very handled very smoothly from TotalCAE side. And last thing I want to mention is the team. TotalCAE team is very responsive. So in all the situations, we get a very quick response from them, which is definitely very important to the CAE engineer here. Okay, yeah, that's all I have.
I appreciate that. Thanks for the kind words. And then let me just change back the presenter here, and then just one moment. All right, next. Well, I appreciate that. That was very interesting, and I think that I would look really forward to being able to drive in the Lucid Air. Next we have, we're going to hear a bit about from Isaiah Wiener, who is the Senior Manager of Solutions Architecture at AWS. So I'm going to pass control over to Isaiah here.
Thank you very much.
Isaiah, did you want to ask for control, and then you'll?
Yeah, I think I've got it.
Okay, thank you. Thank you, Isaiah.
Awesome. So, Guang, I just want to say thank you for being the voice of the customer. It's super important. Here at Amazon, everything we do starts with the customer and works backwards from there. It's a really important part of our process, and it's something that we admire in our partners who do that too. And as you saw, the how was your experience today feedback button that TotalCAE customers have, you can see how important it is to TotalCAE that their customers are having a good day. So if you've ever talked to anybody at AWS about HPC workloads in the cloud, they probably showed you something like this. And this is very similar to how things look behind the scenes at TotalCAE. And it absolutely is something that an engineer probably should have no former experience with, and I wouldn't blame you if you wanted nothing to do with it. At the end of the day, you want to solve your problem, as Guang said. You want to focus on the engineering problems. And actually, I think that this is super important, just generally across all the sciences. That our scientists should be able to work on science. This world's got a lot of problems. We got to fix them. So I want to talk about sort of one of the things that is important to us in APN, which is the AWS Partner Network, about working with folks like TotalCAE, and specifically how TotalCAE makes it easier for you, the customer, to make sure that all of those things are taken care of. So why use AWS to begin with? The main reason, honestly, is that when you go to the cloud, and a lot of people, when they think about the cloud, they think three things, right? They think it's immediately available, it's infinitely scalable and free, and you kind of have to pick two. You can't have all three at once. And so when we think about the cloud, one of the things that people go to AWS for is this idea of a virtually unlimited infrastructure that allows you to scale on demand very quickly, and you'll only pay for what you use. And TotalCAE perpetuates that in your customer experience by you only paying for what you use. And for an on-prem installation, you're sort of limited to the fixed size of your cluster. And so if you need to go from hundreds of instances to thousands, it's really hard to do that on-prem unless you've planned significantly in advance. In AWS, we enable this elasticity, and TotalCAE enables that elasticity for you. So by eliminating the resource limits and helping you scale your cluster as high as you need, when you need, you can actually reduce your time to market or your time to publication or your time to prototyping. So how do we achieve this, actually? So the way we achieve this has largely to do with the fact that already today, our compute platform is anywhere you need it to be. And whether you're a big engineering enterprise with R&D centers and operations all over the world, or an SMB enterprise in one or maybe at most a few countries, AWS and Altair can likely provide you with, AWS and TotalCAE can likely provide you with a deep infrastructure and wealth of services near you that not too long ago would have been impossible. And so this is actually why software as a service solution like TotalCAE is so important, because you likely have very little interest in understanding which of our 21 regions to use, how to tackle 66 different availability zones with different data centers. By the way, what's an availability zone? Well, availability zones are our core building block of fault, our fault domains. It's a very important concept for us, but it's not one that you, as an engineer, should necessarily need to understand. So, if you were designing a data center, you would think about an availability zone as something that has its own power infrastructure, something that has its own networking infrastructure, so that when things fail in one availability zone, they don't impact other availability zones. So this is a concept that you, as an engineer, would be hard pressed to have a ramp up on, and TotalCAE takes care of that for you. All right. So along the way, there's smaller components, and this is something that Rod talked about as far as, which instance type to use and why it's important for you to know which instance type to use. But it's not just about the instance type. It's also everything down to what are the components in our virtualization platform that are optimized for HPC, and making sure that you have things like the right drivers installed, making sure that you're utilizing the right configuration files, the right configuration parameters for the applications that you're using. Also, that you're consuming it in a way that fits with your budget. Again, something that TotalCAE takes care of for you. So we mentioned a couple different instance types at the very beginning. There was a great graph that had the LS Dyna performance metrics on it, and it was the C5N with EFA was the fastest in that case. But what does C5N even mean? So we have sort of this model, and this is a model that I'm demonstrating using GPUs. And in this case, the P3 is the instance family, just like C5 is the instance family, 5 being sort of the generation, 3 being the generation in this case. And the capabilities are notated by letters after the number. So you've got the D, meaning you have local instance store, and you've got N, meaning that it uses our snazzy new networking interfaces that go up to 100 gigabit. That's a lot if you're not keeping track of network performance these days. And then you've got sort of how much of the machine are you using. So C5N has a couple different sizes, P3DN has a couple different sizes, and what you get with these different sizes is you get virtual core counts, you get the presence of extra hardware like a GPU or not having a GPU. Some solvers are optimized for having GPUs, some are not. Memory footprints, local storage or not. Local storage meaning like NVMe flash that would be super, super low latency, high performance IO, and then the network performance. And so there's at this point well over 150 variations or permutations of these combinations, and understanding not only which one is going to fit your job use case, but which one is going to be optimized for the solver that you're using is something that can take a lot of experimentation. And one of the nice things about TotalCAE having lots of customers is that they get to provide feedback loops to improve things over time. So if there's a new version of a solver, they'll do their own experimentation, and then customers will run their jobs on it, and you can the results of that job is information that can be used to optimize the best recommendations for new customers and existing customers too, of course. And so that becomes something that TotalCAE gets to see across a wide variety of customers and jobs for, and it helps a lot when you're trying to offer a software as a service offering. And so here you can see what I meant about that the amount of resources that you get based on the size of the host change. You can fit a lot of P3 2XLs in a P3 host, and only one 24XL in a P3 DN. So the networking, the core counts, the CPUs, these are all things that TotalCAE is helping you to optimize so that you don't have to learn about that. The other thing that I mentioned earlier, and one of the things that Rod touched on quite a bit, is the pricing model. So one of those three things that everybody wants the cloud to be is free. The only way to get even remotely close to that is with Spot, but Spot requires that you have a workload that can work with Spot. So there is, it's not like it used to be with EC2 Spot where you'd have a bid and you'd lose your bid and things would go away. So it's a much, much better environment now, but you still have to know how to manage our Spot model. And if you don't, people often end up going the on-demand route or the reserved route or some combination thereof. In fact, it's totally normal and in fact recommended to use a combination of these different pricing models. But if you're not a ITC ninja, as was stated at the beginning, it's not something that you maybe know about. And so again, this is one of those places where inside of APN, we really value folks like TotalCAE for being able to help us deliver this to customers in ways that customers don't actually need to worry about those things. So, and at the end of it, what you really get is you get an environment where you can run your CAE workloads in the cloud on AWS, and be able to iteate faster, and as was evidenced by what Rod was saying about having a remote visualization workstation where you wouldn't have to pull down a 200 gigabyte file, change one thing, and re-upload it. We believe that when you have your compute closer to your data, and you have the ability to sort of use that lever where the vast compute capabilities of the cloud are able to be utilized by somebody without having to become a cloud expert, we believe that this is something that ultimately creates a good customer experience in the long run. And for us, our flywheel of success, what does success look like for us? It's when our customers and our partners are able to build their businesses through the cloud, and solve the problems that they're facing every day in the cloud. So I'll pause there and hand it back to Rod for beginning of our Q&A. But to show you how much we mean it, we're working with TotalCAE to give you a $500 cloud trial credit so that you can get started with your CAE workloads on TotalCAE and AWS.
All right, thanks, Isaiah. So yeah, I think that I wanted to say thanks again to our presenters at both Lucid and AWS today. If you have any questions that you think of afterwards, feel free to email us. You can email us at info@totalcae.com, and I'll be happy to answer it. Let me just look at the chat real quick and see if anybody had any questions. Just one moment. All right, looks like I see one question here, was if I have a cloud, can I have India engineering team access it? So that is a good question. So one thing about the cloud is that while there's data centers all over the globe. So while it is in fact true that if you had a centralized cloud, kind of like an on-prem cluster might be, that you could have remote areas access it, what we generally do is we try to put the cloud close to the user. So we would put a cloud in Mumbai, for example, and then that will minimize the download time. It also kind of eliminates some of the licensing aspects of it. But typically, because you can spin these up and down in any kind of location, we try to have the cloud close to the engineering resource to minimize download time and make it more accessible. All right, then do you sell licensing? So TotalCAE is kind of the Swiss. We don't sell licensing. However, we will work with your ISV to host the license server for you. So we will host it. We will manage your license server either in the cloud or on premise. And then we will help you with the technology to forward it to the cloud. But we do not sell actual licensing. So you wouldn't buy like Abacus tokens from us. Or MSC campus licensing, that you would still get from your vendor. And I think that there was an engineering question here for Guang, which I will have him handle offline, and I think that was it. So if I appreciate everybody for coming on the call today. If somebody did just ask, can you do FSI and Ansys Workbench? So yes, you can. We do support Ansys Workbench. You would basically use that cloud workstation as where you would run Workbench, and then that would run just like you're used to. It hooks up just like an on-premise system would to the cloud, exactly the same way. And so that you don't typically run Workbench on-premise and then point to the cloud just because there's some the internet latency and that data transfer. We usually we'll run Workbench on the cloud inside of a cloud workstation. So
Rod, can you flip back to that slide where you had a bunch of different solver logos, just so folks can see it one more time?
Yes, one of them. So that particular question was about RSM, is the technology that's kind of a Ansys technology, particular vendor that lets you hook up to clusters, and so that is supported. So there's many other vendors that have similar types of cloud, I would say, interfaces that and that's why we have a command line and an API. We hook in with many other types of similar kind of technologies to Ansys Workbench and RSM, and they are definitely supported.
It's just like white.
Yeah, well, thanks everybody for joining today. And if you, we had a couple of people ask for the slides, just email us for info@totalcae.com after this, then we can certainly send you a slide deck.
Thanks, everybody. Have a great day.
Everybody. Yeah, have a great day. Bye-bye.